Hello, grade 12s. Please excuse my terrible voice. I have lost it from coughing, but I'm going to do my best to try and get through this. So, today we're going to talk about 2.5, which introduces us to a concept called rate of return and average annual rate of return. So, the reason why these two things exist is because sometimes we want to compare investments and we want to see which one's the best option for us or the best one that we chose in the past to make better decisions moving forward. Now, when we compare investments, it's often really easy to do so if everything is identical except there is one small difference. So, for example, before we looked at an example that everything was identical except there was a different type of interest earned. One was simple interest and one was compound interest. We also looked at a different example where both the investments were compound interest, but each investment was at a different number of compounding periods. When everything's the same except one minor detail, it's easy to make those comparisons. However, we can kind of have a harder time to compare things if there's more than one key difference. So that's why we want to introduce something called rate of return and average annual rate of return so we can have a better understanding of what investment is the best choice over a period of time. So we are going to go straight into an example where we have more than one difference in the investments that we're doing. We're going to calculate the final value or the future value for each of these investments. And we're going to see if we can determine which option's better. If that's not possible or if we're not 100% certain on our decision, we're then going to introduce rate of return and then help really finalize that decision for us. So, in this example, we want to determine the accumulated amount for each of the following investments. Investment 1 is a one-time sum of $52,000 in a guaranteed investment certificate, which we know is a GIC. It has a 1.8% interest rate compounded annually for 3 years. Investment 2, we invest $450 into a savings account that earns 1.7% interest compounded daily. And each month, we are depositing an additional $25 for a total of 3 years. Okay, so in both of these situations, we have very different things going on. Realistically, the only thing that's similar is the period of time. This is both done over a period of 3 years. Now, we can tell that both of these are compound interest calculations that we're about to use, which means we're going to be using our TVM. And we can tell, A, because the word compounded shows up, but also it doesn't specify that it's a simple interest, so by default, we always assume it's going to be compound interest. So we're going to calculate that accumulated amount, aka our future value or final value, for each of these investments. So I'm going to label these investment 1 and investment 2. And I know that when I plug things in on TVM, this is kind of my layout. And I know that's true for both of these. Now I want you to take a minute and try and plug in all of the values from the question into my TVM inputs. Okay, so pause the video, try it out, go. Okay, hopefully you did it. Hopefully you plugged it in, all of that. Now investment 1 is very similar to anything we've done before. So no twists, no turns, should be fairly straightforward. My I% is 1.8. I'm compounded annually. I have a one-time sum, so a one-time investment. My PV of $52,000. It's negative because it's an investment. I know I'm not making any payments, no repeated deposits, so that's 0 by default and 1 for PY. My future value is what I'm looking for. This PMT is end. Wouldn't make a difference if it was beginning in this case because I'm not making payments anyways. And then my N, I take my PY, which is 1, my number of years, which is 3, and multiply them to get me 3. Now this should be straightforward to us at this point in time. We should feel fairly confident in figuring out where those values go and plugging them in. And when we do so, we should get an FV, a future value, of $54,858.85. Okay, investment 2 is going to be a little bit different. You'll notice that as I was reading the question, I highlighted much more in investment 2 than investment 1 because there's a little extra stuff that's going on, something that we haven't actually quite encountered, but something that you may be able to figure out. So I just wanted to see if you could. Here I'm going to start with the stuff I do know for sure. 1.7% compounded daily, so 365. Those two are my go-tos. I know I'm looking for the future value. Now, the other information, I have 2 different investment amounts. Now, I'm not investing a total of 475, so I'm not adding these together, but they go into 2 separate lines. Reminder that this PV is anything that's a one and done investment, what I am starting with at the very beginning. It is not something that's repeated. It is simply something that is one and done. And in this particular case, that 450 is one and done. It's negative because it's leaving my wallet to go into the bank. Now, here I do have a payment. I have a repeated deposit of $25 every single month. So that $25, since it's repeated, it goes under my PMT over here. It's going the same direction as my present value, as my PV. It's exiting my wallet and going into my account. So I still have that negative, and it's the 25. It's the amount of the repeated deposit. Now, because that PMT is not 0 anymore, this PY is something we have to look at. Just like CY stands for compounds per year, C per Y, P per Y stands for payments per year. Here, we're making a payment every single month. How many times is that per year? Well, that's 12. Okay. When I look at the PMT at the bottom, it says end or beginning. Now, it doesn't actually tell me in the question when that payment's going to happen. Now, by default, payments happen at the end of whatever period because you need to wait to get paid before you can make some sort of deposit, typically. So if it does not explicitly say beginning, we will always input end. And when I say explicitly say the beginning, it'll either say the word beginning, but it also might say, oh, you're depositing it on the 1st of every month, which is just like a similar or a different way to say at the beginning of every month, okay? So we're not necessarily looking for the word begin, but we're looking for something that implies beginning. Okay, N we know is PY times the number of years, but my PY is no longer 1, it's 12. And my number of years is 3, and I multiply those together. Now, when I do that, I get a different FV value. And that FV value, I'll give you a moment to plug it in. I want you to see what you get. Okay, if you plug it in, you should get $1,396.24. Okay, now our goal here is to determine which of these options is better. But we can't just look at the final value to determine which one's better because it's not fair, right? In one case, I've invested $52,000. So, like, an interest rate is a percent of the amount that you've invested. And a percent of a larger number is going to be larger than a percent of a smaller number. So, obviously, I'm expecting to make more interest, more dollar amount of interest, I should say, off of a larger valued investment. So I can't just be like, oh, 54,000 is clearly bigger than 1,300. Yeah, then that's better. It wasn't starting off at the same point, right? Like, similarly speaking, if, one of you is 6 feet and one of you is 5 feet, and we're trying to see how high you're able to reach when you jump, and the 6-foot person can jump and reach a height of, 7 feet 5 inches, and the 5-foot person could reach a height of 7 feet. Well, we can't just look at the final height because they were starting off at a disadvantage of being shorter. So we need to not just look at the total final amount. We have to consider different things. Now, because there's so many differences going on here, we actually can't look at these investments and say with confidence which option's going to be better. So, no. Since the investments are so different. Right, and we talk about they're different interest rates, they're different compounding periods, they're different deposit frequencies, right? There's a lot going on. It's hard to make a judgment call. Now that precisely is why rate of return exists. Rate of return is the ratio of money earned or lost. So rate of return can be positive. It'll be positive if we earn money. But also in investments, it's possible to lose money. And we're not losing money in like a bank account or something like that. But we could lose money in stocks, right? We invest in a business. The business doesn't do well. Our money value goes down over time. So rate of return can be negative. But anyway, so we're looking at the ratio of money earned or lost on an investment relative to the amount of money invested. Rate of return is expressed as a percent, and we're going to be calculating it using the formula below. So here's my formula. Now, why do I have two? I have two because the top one is actually the formula given to us on our formula sheet. So I want to make sure that we're used to the kind of the fancy language that it uses. But I did make this kind of simplified version. I feel like that arrow wasn't pointing anything. To kind of look at the language or simplify the language a bit. Now the calculation doesn't actually change, whether you use the top version or the bottom version. The bottom version's language is just simply changed to help us understand what that means and what it represents. So we're not just blindly plugging things in, but we're understanding what's happening. Now, when we look at this formula, the numerator says the current value of the portfolio minus the previous value of the portfolio. Now, a couple things. I want to talk about the word portfolio. Portfolio just refers to the collection of investments that you have going on. Now, it's possible for you to have a portfolio of one investment, but it's also possible for you to have a portfolio of 7 investments. Now, rate of return can be used for 1 or 7 or any amount of investments because it's not just specific to one investment at a time. You can take a look at the portfolio as a whole. So it uses language that's a little bit more broad so that it's clear to us that we can use rate of return on just a singular investment or a collection of investments. So that's portfolio. Other things. I notice that the second half, what I'm subtracting with in my numerator, is identical to my denominator. Okay, so the previous value of my portfolio is identical at the top and the bottom. Now, if we look at this kind of differently worded version, this differently worded version of previous value of portfolio means the exact same thing as the total amount of money that we have invested. Okay? So, when we take a look at the total amount of money that we have invested, that could be pretty simplistic if I only invested once, right? In example 1 or investment 1 from above, I invested one time, $52,000. That's my previous value of my portfolio. But investment 2, it could be a little bit more complex. In investment 2, I didn't just invest once. I invested once of $450, but then I made a repeated investment of $25. Now, when we take a look at this is not an official formula, but it's worth writing down and worth remembering, maybe even worth including on my cue card. But to find the total amount invested, aka the previous value of my portfolio, right? These two things are identical here. We can find that by taking my PV value, the positive version of it, because remember the negative only tells me my directionality, okay? So the positive of that, and we are going to add whatever my payment amount is, my PMT, and we are going to multiply that value by N, my number of payments. So a couple of things when we're talking about this here, when we're trying to find the total amount invested, okay? If I only have a one-time investment, my PV is going to be some dollar amount. We're only including it when it's positive. And my PMT will be 0, so I won't be ending up adding anything. But if my PMT is not 0, say it's $25, like we had in investment 2, I need to know how many times I've deposited that $25. And that's what N stands for. N stands for the total number of payments, right? In this example above, the total number of payments, I make them 12 times a year for 3 years, meaning a total of 36 payments, okay? So this formula, or this kind of shortcut way to calculate it, is going to be an important thing for us to remember, because it'll help us always calculate the total amount invested, which is identical to the previous value of my portfolio. Now, my current value of my portfolio, this guy, is just what my portfolio or my investment is worth right now today. And in this case, that's just my future value. Now, something kind of interesting is if I ever want to figure out my dollar amount of interest earned, I simply go, how much do I have right now minus how much did I invest? And that subtraction, that difference, will tell me my dollar amount of interest earned. A couple of things that I do want to talk about that I will just kind of point out. When we ask you questions in finance, there are different things that we can request, right? And just in this one formula alone, there's actually a lot of different things that I might be interested in. Thing number 1 that I might be interested in, I'll kind of just write it down here, is just straight up rate of return. Right? And that just follows the formula. Great, lovely, amazing. Thing number 2 I might be interested is in total amount invested. which is something that we have to calculate to figure out rate of return. But sometimes that's the only thing I'm interested in, right? Sometimes that's the only thing. And just like we were talking about before, that's my PV as a positive, plus my PMT, that dollar amount, also as a positive, multiplied by N, my total number of payments. The last thing I could ask you about, or another thing I should say I can ask you about, is just the dollar amount of interest. And that's my numerator, right? That's my future value minus my total amount invested. Okay, I'll write it as a formula here. As PV plus PMT so I can ask you different things. So we really want to make sure, A, we understand the difference between these different things, and B, we could identify what part of the formula refers to what, which is why I like this version of it. Simply because it helps us understand what we're calculating a little bit better, whereas the thing above might be a little bit more confusing. Okay. Before we move on and actually calculate the rate of return, we've been talking about it for so long, just want to talk about language for a little bit. So, rate of return exists. Rate of return is something that I can have for a single investment or a portfolio. But sometimes it's referred to as an average rate of return. It's used as an average rate of return, oftentimes with stocks, mutual funds, or with a larger portfolio. Because when we calculate, let's say, the rate of return for stocks, maybe I'm looking at my rate of return over a span of, 10 years. Well, stocks fluctuate on how much you get back from them. Sometimes you might get, let's say, 5% return in 1 year, but then 2% in the next year, and then 7% in the third year, and then you're actually losing in the fourth year, right? It fluctuates. So when I calculate my rate of return, it's not actually what you're seeing as a return every single year. It's the average return over the span of time. We also use average rate of return when we're talking about a larger portfolio because, similarly speaking to stocks, you could have a bunch of different things that all have different rates of returns. So maybe you have a GIC that's for a rate of return is pretty good, and a checkings account that has a rate of return but it's much lower because your interest rate is lower. You might also have a rate of return for, let's say a savings bond. But all of those rates of return aren't going to be identical. So when I'm calculating the rate of return for my portfolio, it's an average. Okay? So average rate of return is the same thing as rate of return. All right. We're going to start going and looking into actually calculating the rate of return. We've got Colin. He makes an investment of $6,000 that earns simple interest. Okay, simple interest of 5% over a 7-year term. What is his rate of return on his, Colin, investment after 7 years? Okay, now when I take a look at the rate of return formula, I want to look at something in either one or two ways. I can look at this as dollar amount of interest earned over the amount invested here. In my simple interest calculation, there are two ways I can kind of approach this, right? If I'm looking at that bottom formula, right, we use capital R of R as a shorthand for rate of return. My interest earned as a dollar actually is just straight up I in my I is equal to PRT formula. And in this scenario, Colin's not making a repeated payment. We don't know how to actually tackle that in the simple interest. So his total amount invested is actually just going to be his principal. So in this particular case, for simple interest, My rate of return is just simply my I value, my interest earned as a dollar value, over my principal times by 100%. So, as I do this, I'm actually going to do this in two ways to talk about the different ways we can do it. So the first way is going to be that. I'm going to start by calculating I. I know I is equal to PRT. I know Colin invested $6,000. I know my rate has to be expressed as a decimal. And I know he does that for 7 years. Now I can plug this into my calculator. And when I do that, I should get $2,100. Now, using that value, we can figure out his rate of return, which in this case is my capital I over my P times by 100%. All right, and you're going to plug that in. And when you plug that in, you should get the number 35%. Now, when I take a look at rate of return, a couple of things that I don't want you to freak you out about when you look at your answers. Your answers for rate of return can be all over the place. They can be negative because you could lose money. They could be positive because you could earn money. But they could also be ridiculously high and ridiculously low. Okay? If you're earning money but like very, very, very little and you're doing it over a short period of time, it's not unheard of to see an answer that's like a decimal of a percent. That is okay. That is normal. That is not a red flag. Okay? If I'm calculating a rate of return over a really long span of time, or if I have a really high interest rate, let's say, it's possible that my rate of return can be over 100%. Okay? A rate of return of exactly 100% means that the dollar amount of interest I earned is equal to the amount I've put in. But sometimes, let's say you invest money at 18 into your retirement savings plan, and you don't touch that until you retire. Let's say you retire at, 58 to make the math easy. That's 40 years. And if you're not touching it for 40 years, well, gosh, I really sure hope it at least doubled, because that's a really long time to have your money invested for. So it's okay if you're calculating rate of return and you get 200, 300, 400, 500%. That is also okay. I don't look at rate of return very often and think that value's crazy, it's uncommon, it's a red flag. I see more of like my N values being negative in TVM, or like my dollar amount being astronomically large or small, or going in the opposite direction I was expecting it to, as a red flag. Rate of return is a lot harder to find as a red flag if the value, like it's harder to see what that value is. So 35%, totally great. Okay. I want to talk about the same example, but calculate it using the more official formula that we see in our formula sheet. So the current value of my portfolio is my future value, or it's my accumulated amount. It's my A. So if I'm looking at simple interest, I'm looking at this. I'm looking at my A value. And you could plug this in with me if you want, or you could just watch along, because we're going to get the same answer either way. But when I do this, my future value, my accumulated amount, ends up being $8,100. Now, when I made this calculation, there's a couple of things that I want to note. This is my current value of my portfolio. this value is my this is my interest earned. And this value is my previous value of my portfolio. Which means when I'm looking at my rate of return formula, and if I'm using that like longer, fancy language official one in the formula sheet, the formula says that I take my current value of my portfolio, I subtract my previous value of my portfolio, I divide that difference by the previous value of my portfolio, and I times by 100%. Well, this just ends up with the exact same numbers, because 8,100 minus 6,000 is still 2,100. And so I end up in the same place, and I end up with the same percent. Okay? So I did want to show you that you can do this in both ways, but by understanding the rate of return formula, understanding what the numerator actually is and what the denominator actually represents, sometimes you can get there a little bit more quickly, right? This was a much faster way to get there because I understood what that numerator actually means and what that denominator actually means. So we're not looking for a I can plug this in type thing. We're looking for an understanding so we could tailor our strategies or tactics for the question at hand. Okay. Next example. We've got Justina. She invests $35,000 into her RRSPs, which earned 3.1% interest, compounded semi-annually. What will her rate of return be if she retires in 28 years? Okay. I want you... I don't know what I want you to do. Okay, taking a look at this, reading through it. I know this is how much she's investing. This is my interest rate. I know it's compounding semi-monthly, and I want to figure out rate of return. Now, when I look at rate of return, I need to know a couple of things. I need to know my FV. I need to know my PV, my PMT, and my N. And that's a lot of different things. Now, I don't have all of those things given to me in the question, right? I don't have my FV at this point. So I know I'm going to need to calculate my FV to get there. And to do that, I use TVM. Can you please take a moment, pause the video, and calculate your FV? If you are feeling like you want to give it a go, and I hope you do, I want you to see if you can then take that future value and plug things into your rate of return to get that answer. Once you've given it a shot, start the video and go along with me. Okay, I hope you paused it. I hope you tried. So NI percent, PV, PMT, FV, P per Y, C per Y, PMT. Okay. As we go here, 3.1% is my go-to, no problem. It's semi-monthly. Remember, semi is every half month, and half months happen 24 times a year, so my compounding period is 24 times per year. Now, I know that my PV is $35,000. It's negative because it's an investment. It's leaving her money, her account, her wallet, and going into her account. I don't have any repeated payments, so PMT is 0. PY is auto by default 1. I'm looking for FV. PMT is auto end. And N. N is equal to 1 times 28, which is, of course, 28. Now, when you plug this in, you should get a future value of 8332828. So $83,328.28. Wonderful. If you got this far, awesome work. Now I do want to find my rate of return. Now my rate of return, if we're using my formula at the top, in my formula sheet, current value minus previous value over previous value. We're going to use that setup, but I just want to talk about what that means so we understand it a little bit more. Current value is what we're at right this very moment. It's the future value of this. I'm going to actually write it in like symbols before I write it in numbers. So I'm talking about my current value is the same as my future value in this compound interest example. My previous value is going to be my PV, that's positive, not counting the negative because it just tells me directionality, plus my PMT times N. Now, in this case, my PMT is 0, so when I times 0 by 28, I'm not adding anything here. And that's totally cool. Sometimes they won't have any PMTs, many payments, repeated deposits. That's totally fine. But I do need to make sure I'm always considering it. And my denominator is going to be the same as my previous value. And of course, I take that and times by 100. So at this point in time, I'm just going to plug in those numbers. I know my FV was 83328.28. My previous value was 35,000. I'm inputting it as a positive value. I just have a subtraction sign. That's why there's a subtraction there. But remember that negative doesn't tell me about the money. It tells me directionality of the money. And of course, I'm adding 0 times 28. But 0 times 28 is 0. So I don't actually have to show that. Which means my denominator is going to be the same. And I'm going to multiply that by 100. Now, when you plug this in, please do this either in multiple steps or don't forget the brackets. If you plug this in as one step, you need to put brackets around my numerator because otherwise it will do the division before the subtraction and you will end up with an incorrect value. I typically, when I plug this in, will type in the numerator, hit enter, then do the division, hit enter, then times by 100, and hit enter. When you plug it in, I hope that you are able to get a rate of return of 138.08%. Okay? Now, a couple of reasons why this answer makes sense. Oops. We started off with 35,000, and we have more than doubled. Right? 35,000 times 2 is 70,000, and we're at 83. So if I'm doubling my amount of money, I'm talking about how much interest, what my return is on my investment. If I get a return of 100%, that's the same amount I put in. I'm getting that amount back in addition to my original amount. So it makes sense that it's over 100. Remember, rate of return is always expressed as a percent. That's why there's this percentage in my formula. But just, it's okay that this number is over 100%. It is normal. Okay. Now, rate of return, super great, super awesome. Sometimes it's just worthwhile to look at rate of return for an investment over a span of time because instead of caring how it does every single year, I care more about how it does overall. But if I want to truly compare one investment to another, I have to either use rate of return when my investments have been invested for the same period of time. So if they've both been invested for 6 years, I can use rate of return. But if one has been invested for 6 years and one has been invested for 38 years, again, we're starting at another unfair advantage. Right? The one that's been invested longer has more of a possibility to earn money, to earn more interest. So if I want to truly compare them, I want to make sure I'm comparing them over the same span of time. So we can't just use rate of return. Instead, this is where we introduce average annual rate of return. Now, the key word that we're looking for that's different here is the annual, because remember, average can be thrown in front of rate of return. It doesn't change anything. It's just talking about like this particular situation that I'm in. It might not be the same every year, so we're taking the average. Here, same idea, except we're looking for the key word of annual. If I do not have annual in that phrase, it's either just average rate of return or rate of return. I'm talking about what we did before. I'm talking about this. As soon as I see the word annual, I am taking it one step further. Now, the nice thing about average annual rate of return is the calculation is really simplistic. All I do is I take my rate of return as a numerator, expressed as a percent, and I divide it by the number of years it was invested for. So if my rate of return is 100% and I've, invested that for 4 years, 100% divided by 4 is 25%. Easy peasy, boom, done. That average annual rate of return allows me to directly compare two investments that have been invested for any period of time without one having that unfair advantage. Okay. We have 2 examples, then we're done. So let's jump into it. Pirate Jack Johnson invests $45,000 of his treasure in mutual funds. After a very successful 7 years, he withdraws his investment and ends up with $152,798. What is Pirate Jack Johnson's average annual rate of return? Okay, keyword that I'm looking for, that I'm not just calculating rate of return, is annual. If I see annual, that's one step further than rate of return. Okay. Now, if I want to find this annual rate of return, of course, I need to know the rate of return first. It didn't tell me the rate of return in the question, so I've got some work to do. However, the work is kind of minimal because it tells me how much he invested and how much he ended up with. AKA, he tells me the previous amount of my portfolio and it tells me my current value of the portfolio. So I actually don't have to do any TVM, simple interest calculations, partially because they don't give me enough information for that anyways. But that's what I've got. So I'm going to start by finding my rate of return. My numerator is my current value or my ending up value of my portfolio, subtracting my previous value or my starting off, my total amount invested in my portfolio, divided by that previous value of my portfolio, aka the total amount invested. Of course, times by 100%. If you plug this in, please make sure you do so with brackets to get that answer. Now, before I plug this in, I'm expecting a really high rate of return because my investment has not just doubled, it has more than tripled. So if doubled is 100%, tripled would be one more 100%, so 200%. So I'm actually anticipating a rate of return of over 200%. Now, this rate of return is not my final answer when I do plug it in. So I am keeping more decimal places. Oops, I think there was one extra decimal place. There we go. I'm keeping more decimal places because it is not my final answer. I want my average annual rate of return, which we shorthand by AA, R of R. And I simply take that number and I divide it by my number of years. And that was 7. This is, in fact, my final answer. So I am rounding that final answer to 2 decimal places. Okay, couple of things. My rate of return tells me my overall big picture for the longevity of the investment. My average annual rate of return tells me on a per year basis. Okay? If I had a different investment, if I was comparing investment 1 and 2 from that first example, I could do so by comparing the average annual rates of return, not the just regular rate of return. Because in that very first example, we invested for 3 years. Here we're investing for 7. So there's an unfair starting ground with Pirate Jack Johnson if we compared them directly. Okay. Last question. Terry the trainer. Terry the trainer decides he wants to purchase 6 shares of a new running shoe company called Bounce for $2,900 each. Unfortunately, the company doesn't do so well, and after 3 years, Terry withdraws his money, only to be left with $17,200. What is Terry's rate of return and average annual rate of return? Okay, so a couple of things. Hopefully we'll look at this and we're like, okay, we can't do TVM because A, we're not asking to find like an interest rate, and B, we're not given an interest rate. We're not doing simple interest for exact same reasons, okay? But we are looking for rate of return and average rate of return. And because all that information, we're not doing TVM or simple interest calculations, it must mean that the question actually gives me enough information. Now, looking at this, I know what he ends up with. And indirectly, I know what he started off with. I say indirectly because he did not start off investing $2,900, right? We talked about Terry didn't do so well, which means he must have not made money. But if he started off $2,900 and ended up with $17,200, that makes it sound like he did quite well. Well, why didn't he start with $2,900? Because he bought 6 shares, each worth that value. So the amount he originally invested, his previous value of his portfolio, would be $2,900 times 6. Plug that in, and we get $17,400. So that is how much he originally invested. And this is how much he ends up with. And we want to find rate of return and average annual rate of return. So, rate of return is where we're going to start. We start off with my current value of my portfolio, my $17,200, subtracting my previous value, how much he originally invested, which is $17,400, over the previous value, which again is how much he originally invested, that's $17,400, and timesing it by 100%. Now, Terry lost money. We are expecting as a result for this rate of return to be negative because we're talking about a loss. Again, if I'm plugging this in one step, please don't forget the brackets. And I end up with negative 1.149425%. Now, I will round it because I want 2 different answers. Right, I want rate of return. So negative 1.15% is my rate of return. But I didn't round it right away because it's not my only final answer. And I want to use that non-rounded value for my other work. So I found part of my question, but I want to find all of it. Oops. And my annual average rate of return is my rate of return divided by the number of years. Now in this case, Terry's been investing for 3 years. So we end up with negative 0.38. I'm rounding here because it's my final answer and there's no other work that I'm going to be doing with it. So this is what I got. Back to rate of returns and what values are normal. Negatives are normal and losses, that's totally cool. I am not thrown off by a decimal in my percent. I am not looking at 0.38 and suddenly multiplying it. I'm not suddenly multiplying it by 100 just because I'm thrown off that it's a decimal. Decimals are cool. Decimals don't faze me. I've done all of the steps and I feel confident in what I did. Okay? that's what we've got. So quick little recap. Rate of return can help us compare investments. Could also give us meaningful information about our investments over time. Annual average rate of return also helps us compare investments, but it's best for comparing investments when my investments have been invested over different periods of time. The word average doesn't imply that it's rate of return or average annual rate of return. The word average just tells me that I'm looking over a span of time and looking for what that average return is, or I'm looking over across multiple investments, and we'll deal with that a little bit later in this unit. That is it. That is all. Have a great day. Hope to see you soon. Bye.